Welcome to yearly past paper session of S1. We are starting with February March 2021 paper. Let's look at the first question. It says a fair spinner with 5 sides. So let's start underlining. It's a fair spinner. There are 5 sides. These are the 5 numbers. It is spun repeatedly. So the number of trials is not given. Remember this first statement, the number of trials is not given. The score on each spin is the number on the side on which the spinner lands. That means you can either get a 1 or a 2 or a 3 or a 4 or a 5. And the probability is 1/5 for each one of them. So either this question is about binomial or this question is about geometric, or maybe it's a combination of both. So let's see which one is this. In the first part, it's saying find the probability that a score of 3 is obtained for the first time on the 8th spin. Definitely this question is about geometric probability distribution. Why? Because of 2 reasons. The number of trials is not given and success is being asked on the 8th spin. That means first of all you would write X follows a geometric probability distribution with probability of success 1/5. Secondly, on the 8th spin, that means there would be 7 failures and there would be the last one would be success. I usually don't use a formula in this one because it is common sense. So therefore the formula is something like this. Probability X is equals to R, that is of success is P, that only comes 1, and Q comes out to be R minus 1. That is the official formula for this, and naturally you know that this is derived from the geometric progression of P1. So therefore this is the answer for this one. Now it's your choice whether to leave the answer in decimals or fractions. I personally prefer fractions. So this bottom one is 5 raised to power of 8. This top one is 4 raised to power of 7. Write both of them separately and then you obtain your answer. So this comes out to be 16384 separate, 5 raised to power of 8, 390625. 390625. This is exact answer and there is no approximation needed. Now a lot of you are good at working, but then they are careless about the approximation. So what's the use of so much effort and dedication and investment of time and energy when you cannot take care of it? So take care of every single mark. It's that one mark that can make you slip from an A star to an A or A to a B or B to a C. So take care of everything. Do not underestimate the paper. Show examiner everything. Second part. Find the probability fewer than 6 spins are required to obtain a score of 3 for the first time. So again it's the same thing. Score of 3 for the first time. And let me write one thing over here. That is when they say score of any number. So score of getting a 3 is 1/5 and score of not a 3 is 4/5, because that was so obvious that I forgot to write. But again, we are learning. Do not forget to write anything, write every single thing. So now it's still the same thing, but this time it's saying fewer than 6 spins. Now remember when we were studying this chapter, these were the 2 important inequalities that we need, and just use it as a result. The first inequality is probability X is greater than N. That is this one, Q raised to power of N. This is what you get after the working and understanding and everything. And probability X is less than or equal to N is 1 minus Q raised to power of N, which I have written over here. So if I copy these two and let me paste it on that page. This is the examiner report. This is the paper. So if I paste it I don't know, for some reason it doesn't work. So therefore, probability x is less than or equal to n is 1 minus q raised to power of n. Probability x is less than or equal to n is 1 minus q raised to power of n, and probability x greater than n is q raised to power of n. Now it says fewer than 6. Now none of this thing belongs to neither this category or this category as such, unless I make a adjustment. Fewer than 6 is the same thing as at most 5. Am I right? Because the word at most include lesser than or equal to 5. So fewer than 6 is lesser than or equal to 5. Now it belongs to this category. This n is 5. So probability x is less than or equal to 5 is 1 minus q raised to power of 5, which is 1 minus 4/5 raised to power of 5. And that is the answer for this part. Now it's clear, precise thinking that you need in this particular question. So what was the question all about? The question was all about geometric probability distribution. So that's the first thing. Let's move to the next question. The next question is, a person named Georgie has a red, a blue, and a yellow scarf. Each day she wears exactly one of these scarves. The probabilities for the three colors are given as 0.2, 0.45 and 0.35. So it's red, blue and yellow. So there is a red and there is a blue and let me make this yellow. Now let me first draw this thing. So the first branch is red, the second branch is blue, the third one is yellow, like this. So this is red, blue, yellow. The corresponding probabilities are 0.2, 0.45 and 0.35. When she wears a red scarf, she always wears a hat. So now it's the scenario is about wearing a hat or not wearing a hat. So a green line, a green line, a green line, and then a purple line for not wearing a hat, like this. Of course, in the exam, you don't have to draw it so colorful. So this is hat, no, and no. When she wears a red, she always wears a hat. So this is 1.0, this is 0.0. When she wears a blue scarf, she wears a hat with a probability of 0.4, that's 0.4 and 0.6. When she wears a yellow scarf, she wears a hat with a probability of 0.3 and therefore this is 0.7. Now there are 6 options that we have. We have red scarf with hat, red with no hat, blue with hat, blue with no hat. Let me write it a bit down. So this is blue hat, blue and no hat, and there is yellow hat and yellow no hat. There are 6 options. The first one is 0.2 into 1. The second one is 0.2 into 0. This is 0.45 into 0.4. This is 0.45 into 0.6. This is 0.35 into 0.3 and this is 0.35 into 0.7. Now it says find the probability on a randomly chosen day Georgie wears a hat. So that could be this, that could be this, that could be this. Add up the 3 tick marks and then you get the answer. This is answer 1, this is answer 2, this is, let me correct this thing. This thing is answer 3. So therefore, these are the 3 answers and then you add it up. Now the next question. That is, find the probability on a randomly chosen day Georgie wears a yellow scarf given that she does not wear a hat. So now let's focus on the green number. This is no hat. This one is no hat. This one is no hat. So this is the condition. Condition goes down in the denominator. So this is the condition and the condition is Rn plus Bn plus Yn and these answers, which is 0 plus 0.45 into 0.6 and 0.35 into 0.7, whatever the answer is, that goes down in the denominator. So therefore, the denominator is like this, 0 plus 0.45 into 0.6. Let me write the number better, 0.6 and 0.35 into 0.7. And what goes at the top? She wears a yellow scarf. So this one was red and no, and this is blue and no, and this is yellow and no. So what goes up? The yellow thing goes up like this, and this goes at the top. That is 0.35 into 0.7, and then you would evaluate and you would get the answer. Leave the answer in the fraction form. So when you do the calculation, this is what you get. You get 0.245, that's at the top, and the bottom after the addition is 0.515. So now when you simplify it, this comes out to be 49 over 103 if your calculator is in the right mode, and this is the answer that you obtain. So this question was about tree diagram, and it's about conditional probability. So that's question number 2. Question number 3. What is this question about? It says the time spent by shoppers in a large shopping center has a normal distribution with mean 96 minutes and standard deviation 18 minutes. So the question says it all. This is a question of normal distribution. So let x be the time spent in a shopping center. X follows a normal distribution 96, 18 square. Find the probability that the shopper chosen at random between 85 and 100 minutes in the shopping center. So probability x lies between 85 and 100. Probability z lies between 100 minus 96 over 18, because this is variance. Keep that in mind. This is variance, and when you divide by standard deviation. Why? Because z is x minus mu over sigma. And coming back to this is 85 minus 100 divided by 18. So z lies between the two values. Probability z lies between, this is 4 over 18. Of course, you should be converting it into decimals, and this is negative 15 over 18. First write it like this, then convert it. Z lies between 0.2222 and z lies between negative 0.6111, negative 0.6111. Now let me take you to the normal distribution table. Let me erase all the previous marks. And now you see that the probabilities, these are the probabilities. The probabilities are given to 4 decimal places. So probabilities are given to 4 decimal places. What about the z value? This is 1 dp, this is 2 dp, this is the column of add, that's the third dp. So z is still 3 dp. Now coming back to this, when we are doing this thing, that means this should be rounded off, because that's a very common question people ask. That is 0.222, and this one rounds off to negative 0.611. Got the idea? This is 3 dp, this is 3 dp. Now you start the working. This is rule number 7 according to the way I have taught you. That is phi of 0.611 plus phi of 0.222 minus 1. The second question that they ask is that, is diagram necessary? The question is diagram necessary? The answer is no. The reason being, the rules that I have taught you in my regular classes, the rules that I have taught you, that is based upon the diagram, we obtain some rules. So as such, diagram is not necessary. Yes, if you have a lot of time and you're feeling bored in the paper, then draw a diagram, why not? So no, it's not necessary unless you are all done with paper and you have time to spare. Got the idea? So this is what I'm writing over here. 88% of the shopper, and then this part is all done. You just go to the table and you evaluate. I'm just writing down the answer. That is 0.5879. You can also double check. And this is 0.7294 minus 1. The final answer is 0.317, correct to 3 significant figures. Now it says 88% of the shoppers spend more than t minutes in the shopping center. So now this is a question of back solving. Probability x greater than t is 0.88. What is the first thing that you observe? You observe that make sure this probability is at least 50%. That means 0.5 and above. Second thing, there is a greater sign, and greater sign means a negative z value. So keep that in mind and start working. Probability z is greater than t minus what is mu? That's 96 divided by 18. 96 over 18 is equals to 0.88. Probability z greater than a negative value is 0.88. Now go to the table. Let me take you there. So now let me clarify this. And 0.88, that is what I'm looking for. So 0.7995. And I need to add 5. Now this number is coming under the category of 0.8 and then 4, and I think it's 2. So that's a very famous number, 0.842. So coming back to this is 0.842, 0.842, and negative sign, you based it upon the inequality. Therefore, t minus 96 over 18 is negative 0.842. T minus 96 is negative 0.842 into 18. That is some value. Therefore, t will be coming out to be lesser than 96 because the z value was positive. So therefore, the final answer is 74.85, rounded up 74.9, correct to 3 significant figures. So that is the final answer for this particular part. So that was a lovely question of normal distribution, just a basic, finding the probability and then doing the back solving. So this thing is done and dusted. Question number 4. What is this question all about? The random variable. So the first 2 words, 3 words, say it all. This is discrete random variable. It takes the value 1, 2, 3, 4 only. The probability that x takes is such and such. So first of all, write it like this. Probability x is equals to x, that is k, x5 minus x. Probability x is equals to 1. Probability x is equals to 2. Simple calculation. Probability x is equals to 3. Just follow the instruction. Probability x is equals to 4. That is k all along. And then 2 brackets, a small and a big. So that was too small. And then like this, and then like this. X is 1, 2, 3, 4, and 5 minus x is 5 minus 1, 5 minus 2, 5 minus 3, and 5 minus 4. So therefore, the first answer, not this one, the first answer is coming out to be 4k. 2 3s are 6, that's 6k. 3 2s are, that's also 6k. And last but not the least, that's 4 into 1, which is 4k. So now draw up a table, something like this. And this is x. This is the corresponding probability. This is 1, and this is 2, and this is 3, and this is 4. That's 4k, 6k, 6k, 4k. And in terms of k, and the first part is done up till here. Now for the second part, I would be needing all these things. So sum of probabilities, this is now working for the second part, for part B. They don't label the Roman numeral anymore, so they are starting with part B. So part B is sum of probabilities should equal to 1. So therefore 4, 6, 10, 4, 6, 10, that is 20, k equals to 1. Therefore k comes out to be 1 over 20. Now they are asking for variance, but before that we need to calculate what is expectation of x. So therefore expectation of x is sigma RPX. That is multiply each number by its corresponding probability. 1 into 4, 2 into 6, 3 into 6, 4 into 4, and don't forget to multiply everything. I've taken actually k common out. So k is like this. That's 4 plus 12. That is 16. 16 plus 18. That is 34. 34 plus 16 is 50. So that is 50 multiplied by k, which is 50 into 1 over 20, which is 5 over 2. So this comes out to be 5 over 2 or 2.5. That is the answer for the first part. Now, expectation of x square, that is sigma p x square, that is 1 is your value, that's 1 square into 4, that's 2 square into 6, that's 3 square into 6, that's 4 square into 4, everything added together multiplied by k. So this thing after the calculation, I don't have it separately and I'm not in a mood to calculate it right now. So let me write the formula. Variance of x, that is expectation of x square minus square of expectation of x. So that is this value that you will get, minus 2.5 square, and definitely your answer will come out to be 1.05. So that was a straightforward question of DRV. Now let's look at question number 5. What is this question all about? So now question number 5 is about a data is given, and this is a frequency distribution. That is the first thing that you should observe. So first of all, it's a question about frequency distribution, and they can either ask for histogram, they can either ask for CF curve, they can ask for mean and standard deviation calculation. That's something that you need to observe. Second thing that I observe is that this thing that's given, this is class interval. It's ending at 4 and then it's starting at 5. It's ending at 10, starting at 11, and so on. So that's the kind of data that's given. So it's class interval. They're asking us the cumulative frequency graph. First of all, I need to convert it. So let me convert it. And this becomes negative 0.5 to 4.5. This is 4.5 to 10.5. And so on. So the upper class boundary, where should I draw it? So let me make a table here. The upper class boundary and the corresponding cumulative frequency, that is what needs to be drawn. So this is like this. And let me draw a few lines. So 1 and 2 and 3 and 4 and 5 and 6, something like this. So now the upper class boundary of the first class is 4.5. So this is 4.5, next one is 10.5, next one is 20.5, next one is 30.5, next one is 40.5, and the next one is 60.5. I might be needing one extra class, so let me just shift it a bit down like this, and let me add one extra class over here. We will see it in a short while. Cumulative frequency is 12, 12 plus 16 is 28, 28 plus 32 is 60, 60 plus 66 is 126, 126 plus 20 is 146, 146 plus 4 is 150, and naturally it's matching up this number, which is 156. This thing is also done. Now this is distance, and the distance cannot be negative. So even though the upper class boundary of this thing, the lower class boundary is basically negative 0.5 to 4.5, but distance cannot be negative. So that's why naturally I would take it to be 0. So the upper class boundary is 0, and the corresponding value of cumulative frequency is 0, because that is where you will be starting it from. Now what else I need? Let me just erase these extra lines. And that's the table that I have. Then we need to draw it. So I'm just giving you few hinters along the way. First of all, this is your x-axis, and that's not rocket science. Let me reduce it. And this blue one is your y-axis. And what else do I need? I need to label the x-axis starting from 0 going all the way till 60.5. Now this is 0. This is 10.5. Let's make it like this. Or maybe you can just shift the 0 a bit ahead, so it's easy to draw. So for example, this one is 0. And this is 10.5. And 10.5 to 20.5. and 20.5 to 30.5 and 40.5 and 50.5 and 60.5. So that's the easier way of drawing it. Because if I draw a 0 on that side, so that won't be realistic. The origin where the two axes are meeting, that cannot be 0. So therefore, this is 10.5 and then 10 units each, or another option. Let this thing be 0 and let this thing be 10 and this thing be 20 and this is 30 and this is 40 and this is 50 and this thing is 60, and then just add a point on the right side. So something like that. And then you would be drawing all the points, and that is plotting the points. And it says draw a cumulative frequency graph. What goes on the y-axis? You have the upper class boundary. What goes on the x-axis? The y-axis is the cumulative frequency. And the x-axis is the upper class boundary, which in this scenario is the distance in kilometers. So which in this scenario is distance in kilometers, and then you plot it. Now you can either join it freehand, so that will be a CF curve, or you can join it with a short line segments, and that would be a cumulative frequency polygon. It's not a closed polygon. In both cases, the shape of the graph would be like this, ogive. That's how it would look like. Now, what else does it say? It says for 30% of the journey, the distance traveled is d kilometers or more. So now, if I draw a mini version of this graph over here, that's how the graph is. That's how it would look. Something like this. For 30% of these journeys, this is the distance in kilometers, and this is the CF, that's the number of people. Now it says 30% of the journey, the distance traveled is d kilometer or more. Use your graph to estimate the value of d. Now, cumulative frequency is based upon the concept of less than. So d kilometer or more is 30%. That's the same thing as 70% of the journeys. The distance is d kilometer or less. So what you do is that you calculate 70% of 150. So that is 70 and this is 35. That's 105. That is the cumulative frequency. Go to 105, draw the graph, draw a horizontal line, touch the graph, go down and read this value. This value comes out to be D. So that is for this particular part. Calculate an estimate of mean and mean distance traveled for 150 journeys. This table I have copy pasted from there. So it's given like this. This is distance. So this time I need the mid value. Now remember this thing, the mid value is x. So let me write x over here. X is halfway between lower class interval and upper class interval. X is also halfway lower class boundary plus upper class boundary. So 0 and 4, this is 2. 5 and 10, this is 7.5. 11 and 20, that's 31. That's 15.5. And then what else is there? The other numbers are there. That is 25.5 and this is 35.5, and 41 and 60, the mid value is 50.5. And then you have the formula x bar, which is sigma fx over sigma f. So therefore, just carry out the working. 2 into 12, 7.5 into 16, 15.5 into 32, draw a big bracket, plus 25.5 into 66 and 35.5 into 20 and 50.5 into 4. Add it all up, divided by 150, and that would be the answer. Take care of the accuracy. So the answer should be correct to 3 significant figures. So this thing is all done. Question number 6, that's my favorite topic, that is NCR and NPR. C stands for combination, P stands for permutation. First of all, I'll read the whole question. It's using the word caterpillar. First part is about arrangements. Second part is about arrangements. And the third part is about selections. So this is NCR, and the first two are NPR, and this is NPR. That's the first thing that you should label. Second thing is, I'll label this thing. What does the word caterpillar have? So CATERPILLA and R. Now let me highlight it this way. So that's a double A and double R and double L. And then what else do we have? We have C, we have T, we have E, we have P, we have I. So 2A, 2R, 2L. First thing first, that is 11 factorial divided by 2 factorial, 2 factorial, 2 factorial. The first 2 factorial is for the A's. The second 2 factorial is for the R's. The third factorial is for the L's. Second part. Find the total number of different arrangements of 11 letters in the word caterpillar in which there is an R at the beginning, a R at the end, and the two A's are not together. So R at the beginning, R at the end. So R at the beginning, R at the end. So there is just one R, nothing is happening. This is 1, this is 1. If I want to draw a box, that would be better. So this is a box, one possibility, one possibility. It's an identical alphabet. So it's not 2 P1. It's not 1 P1. It's just 1 1. And then how many alphabets are left? 9. And the two A's are not together. So 2 R's are used, 2 L's are left, and CTEPI. So let me write it like this. C T E P I and 2 L's. And then you need to separate the 2 A's. So 1, 2, 3, 4, 5, 6, 7, 8. So the A's could be anywhere. So you would say 8P2 divided by 2 factorial for the A's. Got the idea? What about these 8, 7? 1, 2, 3, 7. So what about these 7? They can arrange themselves in 7 factorial ways, but 2 of them are L's. So L's are the orange ones. So there is an L over here, there is an L over here. So therefore, this one is 2 factorial for the L's. So this is 2 factorial for the L's, this is 2 factorial for the A's. And R's were already used. So that is the working for this particular part. Question number 3. Find the number of different selections of 6 letters of the word from the 11 letters that contain both R's, at least one A, at least one L. So now what do we have? We have double R and double A, double R, double L. Double A, double R and double L. So let me first write the 2 R's, then 2 A's, then 2 L's. So this is double R, this is double A, this is double L, and then you have C, T, E, P, I. And you want a total of 6. Now both R's are included. So this is included, this is included. And there would be many options like this. Let me just label it. So R's are included. So now basically from the rest we have to select 4. That's what the question is all about. Got the idea? Listen to me again. 2 R's are already selected. So you need to select 4 out of the rest. So now, and you need at least one of each. So it could be 1 and it could be 1 and it could be 2. Let me first write all the options. It could be 1, it could be 0, it could be 3. Let me first start with 0. This is 0, this is 1, this is 3, this is 1, this is 0, this is 3. This is 1, this is 1, this is 3. And what else could be there? Can we have some more? Yes, we can have. So therefore, the options are um, at least one of each type. Can we have 210? At least one A and one L. So if I have 210 and I can have 0211, can I have this one? Oh, first of all, my bad. This one, the 0 is not possible. So that's what happens when you try to be too logical, because you are thinking of all the possibilities. So first of all, this is at least one of each. So that's 1, 1 and 2. And this is 1, 2 and 1. And this is 2, 1 and 1. And this is 2, 2 and 0. I think that finishes it all. When you select 1A, you dump the other. When you select 1L, you dump the other. And that's very simple. So basically your calculation is out of these 5. So this one is 5C2, which is 10. This one is 5C1, which is 5. This is 5C1, which is 5. This is 5C0, which is 1. And add it all up, that comes out to be 21 possibilities. So that is the working for this one. Now let's look at this one. There are 400 students in a certain country. Now let me just do one adjustment of this thing, and it goes something like this. Okay. Now it says there are 400 students in a particular school, and what are they asking? Each student was asked whether they preferred swimming, cycling or running, and the results are given below. So it's just one person belonging to one category. So this looks like a table format for probability. So a student is chosen at random. Find the probability student prefers swimming. First of all, the denominator is 400 and the swimming one is 104 plus 31. So 104 plus 31, that adds up to 135 over 400. And let me reduce it, 135 over 400, that becomes divided by 5, 27 over 80, and we would leave the answer as it is. Determine whether the events the student is male, probability of male, and the student prefers swimming, are they independent or not? So now this is probability that the student prefers swimming. That we already have, that is 27 over 80 after the reduction. Probability of male, that's 31, 57, 92. So 31 plus 57 plus 92. So that boils down to, I think 180 divided by 400. So that's 180 over 400, and that is 18 over 40, and 2 9s are 2 20s are, that's 9 over 20. Now what is the intersection of these two? The intersection of these two, that is male and swimming, that's going like this. This is male and this thing is swimming, that is this number, that is 31 over 400. So that is 31 over 400, that is the intersection. So probability of male and swimming, that's 31 over 400. What is the equation for independence? Probability of M and S, is it equal to probability of M into probability of S? This is 31 over 400. I'm not sure. This is 9 over 20. This is 27 over 80. When you multiply, it's not equal. Therefore, the two events are not independent. That is all that is needed in this particular question. So that was the second question of probability. The first one was about a tree diagram. Now the question continues. It's not over yet. It says on average, at all the schools in this country, 30% of the students do not like any sport. 10 of the students from this country are chosen at random. Find the probability at least 3 of the students do not like any sport. And let's continue further. 90 students are chosen. Use an approximation. Find the probability fewer than 32 do not like any sport. So do not like any sport is my success. Do not like any sport is my success. Do not like any sports is my success. Got the idea? Now, first of all, you would write probability of success is 30% and n in this scenario is 10. It follows a binomial distribution 10, 0.30. Probability x is greater than or equal to 3, which is 1 minus probability x is less than or equal to 2. Now, when we will read the examiner report, I'm telling you beforehand that the examiner wants you to show every single step. Do not do everything on the calculator. You can do it for your perfection, for your confirmation, but you have to show every single thing to the examiner. What I'm writing, every single step is a must. That is 10C0 and 10C1 and 10C2. So now this is 0.3, 0.3, 0.3, 0.7, 0.7, 0.7, and the power of 3 is 0.3 is 0 and 1 and 2, and the power of this thing is 10 and 9 and 8. Write everything. Write down individual probabilities, and that simplifies to whatever the answers are, and therefore that adds up 1 minus 0.0228 0.028248 plus 0.121061 plus 0.2333474. Now, these answers I have picked from the mark scheme. If you have 1, 2, 3, 4 decimal places, that's enough. 4 significant figures. 1, 2, 3, 4, that's enough. 1, 2, 3, 4, that's enough. And then you do the subtraction and then you round it off. So final answer is 0.617, correct to 3 significant figure. So let me write it on this side. Every single step on the right side is a must to score full marks on this question. Period. Okay? There is no shortcut. Now, let's move on. 90% of the students are now chosen at random. So, X follows a binomial distribution 90, 0.30. N is 90. P is 0.3. Q is 0.7. Find three numbers NP, NQ, and NPQ. So, 90 into 0.3 is 27. 90 minus 30 is 60, so this is 63. 7 nines are 63. NPQ. Now I'm getting the calculator ready. So therefore, this comes out to be 18.9. Now let's look at my red marker. This and this is for justification. Since NP is greater than 5 and NQ is greater than 5, therefore X follows a normal distribution such, such. What goes in there? This is your expectation. This is your variance. So therefore, 27 and 18.9, that goes in there. Whether the examiner asks or not, do the justification. So this is justification. Justify things. Fewer than 32. Probability X is less than 32. Now what is needed? Continuity correction. This is 32. This is 32.5. This is 31.5. Two options are there. One line going like this. The other line going like this. Since 32 is not inclusive. Since 32 is not inclusive, therefore choose this line. So therefore probability X is less than 31.5. So this is continuity correction, which is a must in approximation that you study in S1. You'll be studying more approximations in S2. Probability Z is less than 31.5 minus 27 divided by square root of 18.9. Use a calculator. Standardize. Probability Z is less than a positive value of 1.035, and from the table you get the answer is 0.850, correct to 3 significant figures. That is the answer for this particular part. And that was February March 2021 S1 paper, and it's all done. And now it's up to you to watch the paper, jot down the things, and do a perfect, immaculate preparation for your exam. Take care.